Alrighty, I see some folks still rolling in, but I think we'll go ahead and get started. Well, welcome back everyone to the second episode in series 2 of the IIP Tips and Tricks webinar series featuring conversations on the introduction to DICOMweb. We're joined today by two phenomenal SIIM favorites and faculty members. Of course, your host for the entirety of the IIP Tips and Tricks series, Herman Oosterwyk, who is the EHR, PACS, DICOM, and IHE instructor for OTEC, in addition to being a consultant and overall project manager for most of OTEC's projects. He participates with the DICOM, HL7, and IHE standardization efforts, serving in various positions and working across a multitude of work groups. We're also joined today by Mohanad Hussain, who's the principal consultant at Techie Maestro, an independent consultant in imaging informatics. Mohanad assists clients with integration and innovation projects and is, of course, a proud member of SIIM for nearly a decade, where he has contributed to the SIIM Hackathon, SIIMcast, as well as the annual meeting. Herman, take it away.
Okay, well, thank you and welcome again. And I mean, like Bradley says, I'm really honored to have Mohanad on my side because we really need a techie master in this kind of a subject. So we're going to talk about DICOMweb. I did quite a bit of discussions and presentation about DICOM. So what is different and why do IIPs, imaging informatics professionals, do need to know about the DICOMweb, which is the latest and greatest, right? So we'll talk a little bit about web protocols, and then we'll make a comparison between DICOMweb and the traditional DICOM protocol. The traditional DICOM protocol meaning the ones that we've been using since the 1993 introduction of DICOM. Talk about a little bit of DICOM email because that's kind of also part of the DICOMweb, some characteristics of web services. And then we're going to dive into the VADU, web access to DICOM objects, which is the DICOMweb. We'll talk a little bit about the different flavors of VADU, the URI, WS, and RS. And then our Techie Master will have a demo to show you how DICOMweb basically works, in the real world. So we have a setup for a virtual DICOMweb receiver, and then we can do some transactions back and forth. And because there's nothing better to seeing is believing, you can really see what is going on over the with regard to the transactions. And then I will take it back in a little conclusion. And then, of course, we have a time for questions. I almost forgot about that. Anytime you have questions, put it in the chat file, in the chat box, and Bradley will sort them out at the end of the presentation. We probably have 5 to 10 minutes left. Any questions about DICOMweb? So let's get started and dive straight in. So why do we, I mean, when I talk about we, why do IIPs need to know about DICOMweb? Well, first of all, it's the next thing. When you hear about fire, you hear about artificial intelligence, and you hear about VNH, all of that is facilitated by DICOMweb. Because, for example, a fire is the new, it's a 7 standard. If we want to access a fire resource and we want to get images, DICOMweb is the answer. Or if we want to connect a zero footprint viewer to a VNA, we need to get images. That's DICOMweb. And also all of the XDS protocols defined by IHE, they use DICOMweb. So web services, it's really the next big thing because everybody today has a smartphone, we're running around the tablets, and we have access from every computer or browser to the internet, so the resources are unlimited. And again, so DICOMweb is really the tool and the mechanism to facilitate that. So it's an emerging technology for enterprise viewing. We've been told that after AI, enterprise viewing, enterprise imaging is the next big thing. And so everybody's thinking about enterprise imaging, and how do we do that again? With DICOMweb. So it's suitable for image uploads for mobile media. So patient comes in the ER. So what does the physician do? He said, oh, okay, that doesn't look too good. Let's take a picture. And there we go, click, and we have a picture. How do we get it into our enterprise archive? DICOMweb, right? Image uploads, very easy to accomplish with web services. A simple app on your phone or your tablet to upload any images that you want. What about your point of care ultrasound? Again, images, very easy to be uploaded. from your mobile devices. We use it also for cloud access, of course, but because the cloud is in the internet, so we need to have web services to provide cloud access, and everybody's going to go to the cloud. It is not necessarily a question from if, but it's more like when, but it's going to be this year, next year, or maybe definitely within the next few years, everything will be to a certain degree in the cloud. And then it's really a better solution than proprietary HTTP APIs. I talked to the developer last week, an AI developer, and I said, so, okay, so you have this great AI algorithm that it tells you whether a patient has a stroke. So, and now what? How are you going to tell that to the EMR or the PACS or the RIS? I said, no problem. We used to have an HTTP call. I said, okay, so what do you mean? Well, it's an open API. Everybody can look at it. It's just published on the website. Well, maybe better using some standard technologies for that instead of using the proprietary. So I think we would like to make sure that we don't proliferate more proprietary solution, but really go to a standard way of connecting. So, and it's evolving to be a popular AI interface option, right? If you have an AI algorithm running in the cloud again, DICOMweb will be the solution to either upload or download the images with results. So that's kind of why we need to know about it, why you need to know about it. So the protocol, so DICOMweb has a protocol, and it's very simple. Use widely deployed technologies. You know, when you buy something on Amazon or you buy a ticket on Travelocity or whatever your favorite Expedia channel is, whatever it is, everybody uses web services, right? A lot of toolkits, experience, people coming out of school right now. When I came out of college, but that's a really long time ago, I was an expert in programming in assembly code and Fortran. Today, it's all about web services, JSON, right? And a couple of years ago, all XML. So these kids coming out of school, you can put them straight to work and have a little app developing these applications using web services. And we use existing infrastructure for addressing. So instead of traditionally DICOM protocol, AE title, IP address, port number, you know, all of that, you know, managing that kind of stuff, we say www. Right, general hospital dot radiology dot pacs dot VNA 01 dot 1245 patient ID. Who's figuring out where that source is of that particular image? DNS, right? Because you have a standard URL. So we use the existing infrastructure. And if you do that query from your laptop at home, simple, you use HTTPS, secure connection, right? The data formats part, the data format part of DICOMweb, we don't want to mess around with. So we left the traditional header encoding, because remember, there are billions or gazillions of images right now around the world that we want to access. So we don't want to mess around with the encoding, with the data formats. We use the same header. The good news is that we actually refined a little bit the protocol. So now instead of downloading a 1.5 gigabyte file, we can say, well, yes, let's take down the header, or let's take only the what we call bulk data, right? So it's even better from a protocol perspective. We use the same old data format, and then we're able to split it up. And it's mobile connectivity, web browser friendly, and it's a companion of FHIR. FHIR is where the whole world is going, right? HL7 is going to be replaced by resources. We want to have a document, a FHIR document resource. We want to have information about the study resource. So FHIR, if we want to have provider information, patient information, all resources connected via this big web connection. And then, of course, then an image resources will be very similar web services using DICOMweb. Okay, so let's make an analogy. So when people talked about DICOMweb, let's make an analogy, and this is a picture of how the real world works, not thinking about imaging at all or healthcare at all, but here's how the real world works. So Louisville Convention Center, this is the convention center where I typically do my face-to-face classes before COVID happened. And basically, if I go to the website of the Louisville Convention Center, there's a hotel conference center, and I can click on a link on the corner and says, okay, how do I get there? So no big deal. I can go, basically what happens is that I have a straight link to Google Maps. How do I, what is the review? TripAdvisor, Ship My Luggage, FedEx. Now, all of those are URLs, links straight to those resources. How can I build an EMR using the same kind of technology? Okay, let's say we have an EMR, electronic medical record, and basically I want patient information, no big deal. I have a patient resource. I don't store patient information locally anymore, because what happens if I change it? A typical hospital has at least 20 to 30 ADT feeds. What does that mean? 20 to 30 locations where patient information is managed in a database. So what happens if I have an update? 20 to 30 transactions. What happens if I need to cancel an appointment? How many connections, how many messages do I need to send out in 8.7 version 2? Alternatively, if we have a single patient resource, I can access it using a FHIR call. The same thing with reports and document management system, single source. My cardiology, my EKGs, and my cardiology information system, my lab and my laboratory information system. And last but not least, imaging, let's say in the VNA, right? Enterprise Archive, where it's central, right? Some countries like Canada have it, the VNA is on the province-based, right? So they have all of these images in a central location. I simply have a DICOMweb URL that provides me that image. So how the impact you see is tremendous, because you could create an EMR, electronic medical record, being a shell instead of this big silo and having everything archived in there with the documents and the EKGs and the this and the that and the database with all the patient information. All of that is just a shell. It's like a web page linking to the resources, including the images, right? So you can see what a big advantage that they have. Now, first of all, let me back up a little bit. So if you don't know anything about web protocols, you might have heard about the DICOM C-store, C-find, C-get, C-move, associate request, and whatever. How does it compare with the web protocol? Well, web protocol is HTTP, right? HTTP, and I think everybody says HTTP. I think it's called hyperlinked transferred something protocol. Everybody says HTTP. Oh, actually, here's what it says: hypertext transfer protocol, right? We use standard port 80, or we have a secure port if we use the secure connection. And so instead of doing the C-store or the C-find or the C-get, the C-move, we use a post to submit the data. We use a get to request the data. And basically, we get then a response back. For example, if everything is okay, it says HTTP 200 okay, and then we get the information back. This is an example where we have an XML, or it could be a JSON. For example, we do a JSON request as well. So very simple, just take out the C-find, C-get, C-move, and so on, and replace it with the post and get. And so you see so many examples of we want to use the commands. In HTTP would be the put or post. This is an equivalent for the SQL insert, or a get for the read. See, equivalent to the SQL select, and the put or patch, it will be the equivalent of the update and delete. See, here's the good news: we now have a delete option. There's no DICOM delete, but now we have a delete option as well. Okay, so how do we do DICOM over the internet? We can using email or HTTP, right? Email, it's a little bit of a niche application, and there's actually a very good definition of email in DICOM, specifically for dentistry. For some reason, the dentists like to send occasionally a batch of images to their orthodontist or the surgeons, or the implant specialist or the labs. So that's where we see emails being used as well. And basically, they take the images and it's almost like a virtual CD. They take the images to the DICOM there and they zip it, and they use a secure email connection. So we can use pull using HTTP or HTTPS for frequent transactions. Then that would be the second option. So either email or HTTP. Both use the Part 10 files, including Part 2, Group 2 as a meta files, because when we do a traditional DICOM connection, how does it work? We set up a connection, let's say from the CT scanner to the PACS system. The CT scanner says to the PACS, hello, I have some CT images and also some structured reports that contain some dose information. Do you understand that? So we negotiate an association. So part of that association will be the format that it comes in, JPEG, MPEG, explicit VR, little endian, big endian, right? Kind of the file that goes back and forth. Now, this whole negotiation part is not included anymore because we do a straight put, right, or post. So we need to then include some of the information in the header, the metadata header of it that we call in a part 10 file. Okay, so a few slides on DICOM email. So DICOM email follows the media exchange format, uses the DICOM directory. So it's almost like a virtual CD that is being sent through an email. We have a general purpose zip email, secure email, and a one specifically for dental applications, right, with some restrictions regarding the subclasses. We say for dental, we can only use these particular intraoral and a couple of other subclasses file formats. So we use a container, and so simple packets. So we have a standard MIME encoding for compression and signatures. The sender will create a zip file, receiver detach and extract the zip file, and very easy, we will be all set, right? Now let's talk about how we implement DICOMweb. Now let's say a developer or a PACS vendor has a existing PACS system. So what the existing PACS system, they typically have a SQL interface, right? Depending on the database that they're using, a Formix, Sybase, Oracle, whatever it is. And so the PACS vendors, when they connect their own workstations, they do a SQL select statement to give, for example, a work list, right? That is how currently the PACS vendor, most of the PACS vendors talk to their own database backend. What about the modality? How does it talk to the PACS backend? Well, they use a DICOM interface, right? So basically, or not only the modalities, but maybe third-party workstations as well. How does the mobile devices? So basically, instead of having the SQL select or the DICOM, we use the DICOMweb interface. So very simple. If you look at the protocol itself, right? Instead of having the update select statement, there could be a middleware before that implements the DICOM stores define secret remove. So that's typically how the interface works today. How we do a DICOM interface? Well, we do the DICOM command, stow, kido, VADU, and basically we'll transfer it to the store, find, get, and move. So relatively simple. You can actually develop a layer on top of the existing DICOM interface if you like to. Okay. Okay, this is kind of important. Be aware of the different VADU versions. So when VADU started actually a long time ago, I think it was early 2000 or something, that as if I remember correctly, we did a simple URL definition to pull up the data. Not used a lot, was some implementations. Then the whole XDS definition came along, XDSI. XDS means cross-enterprise document sharing and for imaging as well. And so there was the first occurrence of a VADU, but that actually were using SOAP encoding, SOAP-based encoding, so web services, VADU WS. That version is deprecated. So that means it's kind of retired from the standard. But if you have a VADU implementation of a few years back, you might still support that. So be a little bit careful with, so by the way, how do you find out again? What kind of VADU you support? Of course, the DICOM conformance statement, right? Go to your device, find out the version and look at the DICOM conformance statement. So what we're looking for is really, and when we talk about is the VADU RS RESTful services, that's really basically what we're talking about. So VADU is this very specific one for web access to DICOM objects. And of course, we have for query, stow is stored to the web, and the universal work list as well. UPS, Universal Procedure Step. So a little bit of a refresher. Traditional DICOM protocol, associate request, right? Associate accept. Oh, my arrows are a little bit out of sync, but basically what happens, you do an associate request, you get an acceptance back, you do your store, boom, 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 you get all the responses back, release request. right? So there's a traditional DICOM protocol, and just as an example how it then would work, in DICOM web services, first of all, no fixed IP. Port number as per HTTP, no AE title, much less overhead, no DICOM toolkit needed, right? Basically, we have a simple request, you get OK back, and all the data would come back and forth. So much less overhead and using existing standard as well. So HTTP GET, for example, the results back. So advantages of this RESTful services use HTTP instead of DICOM. You can retrieve study series instances, like we do with DICOM, traditional DICOM, and frame. Actually, we could do that actually with traditional DICOM, but it's not used a lot. But now it's much easier to do it frame-based. So we have a multi-frame. We have the top 2000 slice CT scanner, and I want to only retrieve the chest. I can do a frame level retrieve, metadata and bulk data, header only, and pixel data only. So get the complete metadata and bulk transfers as well. So here's an example if you want to really know how the HTTP representation is. If you're kind of interested in that, basically the metadata, uncompressed bulk data, compressed bulk data, whatever. So just basically different content types. Content types is where the specification is in the HTTP protocol. So what are the RESTful services? VADU, STO, Kido, and UPS. There was an early version called Mint by some couple of vendors that were implemented. It's kind of retired as well. So traditional DICOM transport, image, header, pixel data, image header, pixel data, image header, pixel data, right? Cannot retrieve the metadata on one image at a time. We cannot stream the data. That's another thing we want on the internet. No end of transmission notification. And we need special ports and protocols. Bulk transport, super cool. I can just take only the headers and all of the data. So I can retrieve the metadata and then find out what I would need on my mobile device, for example. And we can compress it very nicely using zip and retrieve the desired images in bulk and know when the transmission is complete. Okay, standard IT friendly ports. So STO is the first command we're going to talk about. Store DICOM over the web. So we have an image on my phone and I want to put it in the PACS, right? DICOM files or XML data and binary, right? Simplifies the application development, cashless development, deployment, federated data access, one accessibility, right? Kido is the next one. Query interface to DICOM objects. Specify DICOM query. This is your cfind replacement. XML JSON responses. Very simple again, right? Now, again, the VADU WS will initially specify the XDSI. The VADU RS is specified the MHD. What I'm referring to, XDSI and MHD, are different IHE profiles. So MHD is the mobile health devices. So it's where the VADU RS actually resides in. So it's also supported by the IHE profiles. And then FHIR has resources defining the linking of the studies. You have a FHIR study resource, and you can actually, it will contain a link to a study series of sub-instance UID that you can pull with your DICOM web. Okay, now I'm ready to stop share my screen and I'm let Maestro take over. Take care, Mohamed. And by the way, if you hear some, let me mute myself because I have some thunder in the back.
All right, can you hear me now?
Yes, sir, we can.
All right, thank you, Bradley. Sorry, I had a technical glitch and it wasn't letting me unmute. So thank you for the kind introduction, both Bradley and Herman. I'm honored to be here and just give a quick demo of DICOMweb. So without further ado, we're going to get started here. So again, let's quickly kind of review the basics. So of course, the DICOM structure, the hierarchy here is you go patient, study, series, and then images or objects. So those objects could be, annotation objects or DICOM SRs or other types of objects. Again, the sort of the high level equivalent. So what used to be done over cfind in the past is now done over Kido RS. What used to be a CMove is done with WADU RS. This could also be Water URI here, but as you'll see, it's WADU RS is the newest, latest, and greatest. CStore is STO RS. And again, what was originally just called WADU and then was retroactively renamed to WADU URI is now WADU RS. So don't get confused with the different names of WADU. If you can choose, you'd probably want to choose RS because it's the newest and greatest. So what I'm going to do, and all of you are more than welcome to try and attempt this later at your leisure. We're going to go ahead and try to do this in an application called Postman. Now, you can do this in a variety of ways, but I like Postman because it's an application that allows you to explore these web-based APIs in a nice generic fashion. And as you'll see, it has a cool feature where it allows you to basically tinker and figure out what it is, the mechanics of the request you want to put together. And then you can quickly export that into code. Okay, so I'm going to switch to Postman and I'm going to show you very quickly what I've prepared here. And I'm just going to put this window away just so we have full view. Okay, so I'll actually start new just so we have it fresh. So what I've done is I've opened up a tab. This is very similar to what you do in a browser. So I opened up a tab, and what I'm going to do is I have a URL that I'm going to put in. So as you can see here, HTTPS hackathon.sim.org. So we're using the hackathon server /DICOMweb, meaning we want to talk to the DICOMweb /studies, that's standard syntax. And then there's a question mark. So the question mark is a way of denoting that I'm running a query. And in this case, my query is really simple. I'm saying I want anything with patient name equals SIIM star. Now, the hackathon dataset is actually, sorry, the hackathon server is loaded with the hackathon dataset that has patients with the name SIIM, okay? Now, what you'll notice is Postman shows me that it understood what I asked for here, and it actually put it in the parameters part here. So you can either put this in the URL or you can actually use the form here, depending on which one you find easier. What I do need to do, though, is one more thing. The SIIM server is secured using an API key mechanism. Now, today we're going to be using a generic API key, but ideally you should each get your own key to experiment and tinker with this, and I'll explain how to do that later. But for now, what I'm going to do is I'm going to use this generic key. So I'm now ready. And as you can see, this was super simple to put together. No IE titles to configure, none of that stuff. I basically had to put in a URL and one mechanism for authentication, which in this case is the API key. So I'm going to hit send. So now it's talking to the server. And as you can see, here is my result. So I got my result in JSON, which is JavaScript object annotation format, or notation format, I should say. So this is basically the DICOM object. These are the DICOM tag represented using JSON, as you can see. Okay, so this is a super simple hello world type of example of here we just tried DICOMweb and we got something out of it. Now, one thing I want to show you before I forget, this is a cool feature I like Postman. You see where my mouse cursor here is on the right, there is this code button. So when I click that, what I like about Postman is, depending on what tool it is that you like to write your scripts in, this will actually give you handy dandy code that you can basically copy and paste. Let's say you're a PHP developer as an example. So now this is giving you the PHP curl code that you could basically just copy and paste, and it's going to perform everything that we just did, but in a script. So now you can take that and combine it with something that is doing post-processing or something different. There's PowerShell if you're a Windows user. If you're a Linux user, for whatever reason, Bash would be up here. Well, curl, I guess, is Bash. If you're a Python developer, you've also got the different Python methods, so the HTTP client and the request, and so on and so forth. So again, very handy. And let's try one more example here. Oh, I apologize. I forgot to show you one more thing. So the other thing I forgot to show you is in the headers, you saw me specify an API key. The other thing I can also specify is I can also specify an accept header, which is a way of telling the server what format you want the results to be served in. So you notice before I didn't have that accept header, what I did is I got a JSON return. So if I instead do application/DICOM+XML, as you can imagine, this is now going to flip to XML, okay? Now, you'll notice it's not doing syntax highlighting, and we're going to explain in a moment why that is, but I'm just going to manually flip it to XML. So there it is. there's the XML format. So again, it's basically DICOM attributes expressed in XML. So there's your tag number for accession number, and there's the value of the accession number. One small difference you may have noticed between the two is that the JSON doesn't have the tag name, whereas the XML does. Again, minor conveniences or inconveniences, depending on how you look at it. That's one small difference. But there is a bigger difference that I'm going to come back to in just a moment here. Okay. Now, again, what you notice about this whole exercise is that this was extremely easy. I was able to put together a request in pretty much no time. Had I been using DIMC, it probably would have taken me a lot longer, where I would have had to get an AE tile configured maybe on both ends, and then piece together a DIMC command using something like a DCM for chair or something different. Whereas here, you can use tools that are off the shelf. Again, I'm using Postman for convenience, but you could use it pretty much anything you want here that's able to do HTTP-based requests. Now, before I leave this, what I do want to show you is this example. So some of you might be wondering is, what if I don't have the tag name handy for whatever reason? And yes, you can use the tag number as well as the tag name. So if I run this query, I'm going to get the exact same response here. Of course, the syntax highlighting didn't work, but the rest is fine. So this is another way of saying patient name. So you can keep doing that. The difference I wanted to highlight, though, between JSON and XML that is important to note is this chunk right here. And this is actually the reason why the syntax highlighting doesn't work right away. This is what is in HTTP lingo called a multi-part response. I'm not going to spend a lot of time talking about what it is and how it works, but I'm going to summarize it with two anecdotes. The first one is, this is the same format that email uses to bundle things together. So if I'm sending an email to one of you right now, I'm usually going to have a bit of text, which is the body of the email, and then maybe a couple of attachments. So the attachments could be one JPEG image and then one PDF document. So as you can imagine, these are very different formats that are being bundled together. And that's what multipart is. So this is a way of bundling things that can potentially be different or are distinct objects together. Multipart is akin to basically putting things in a zip file, is basically what it is. Now, why does XML return multipart and not JSON is a long story. I'm not going to get into it, but it's important for you to remember that when you are getting responses from DICOMweb, especially KeyDORS and XML, they're going to be coming in as multipart. So you need to be able to process that properly. Otherwise, you can stick with JSON. All right. So coming back here. So we already saw the JSON version. And as you would have noticed by now, it speaks both XML and JSON. So which one do you prefer to use depends on personal preferences, the kind of application you're trying to build, so on and so forth. You know, somebody who's writing a front-end application, you know, something, let's say, web-based, may prefer to use JSON. Somebody doing something on the server side may prefer to do XML. It doesn't necessarily have to be this way. That's just, you know, one potential way. Now, the reason why this is called the REST API is because of what you see on my slide here. So the way you go down the hierarchy is very logical. It's almost like a folder structure. Like imagine if you manually had to store your DICOM files, you create a folder for the study, and then a folder for the series, and then folders for the instances. This is kind of how it works. So there's a path. So if I have a particular study that I want to see, I put the study UID in the path and I add /series. And now that's going to give me information about the series. Or I can say /instances, and it immediately goes down to the instances within that study and shows me results for those instances. Or I can go, as you can see here, study, series, and then the instances. So now I'm looking at instances or images within a specific series within that specific study. So let's try an example here. I've got an existing baked example that we'll just use for easiness sake. But basically what I'm doing is, so if you look at my URL, I've already got a study UID that I've had prepared. If you wanted to do this manually, you basically could just go down the return or the response and be able to pull one of those study UIDs and send it. But yeah, basically what I'm going to do is I'm going to go ahead and hit send. So, oops. Interesting. Oh, my apologies. I need to do series or instances. That's why. So let's say series and send this. So again, I'm going to flip it here. So this is now returning the listing of all the series within the study. Okay. Now I'll quickly explain one more thing about multipart. So the way this works is this weird code you see highlighted on my screen. This is the boundary between the multipart. So if I actually copy this and then I do a Control F, so search for this, you'll notice that it says 204. So that means this boundary actually shows up 4 times in my return. Now, the last one doesn't really count because the last one is just telling me this is the end of the response. So that means in this case, the boundary shows up 3 times, which basically means 3 results returned to my query. And my query in this case was asking for series. So that's really a way of saying I have 3 series within that study. Okay. Now, if I change this and I go instances, so now I'm looking at all the instances within this study. Okay. So let's take that boundary and I'm going to do the search. Okay. So the search is returned 133. Again, we'll subtract 1 because that's the bottom one, the end one. So that means this study had 132 instances. And this response here returned information about each and every one of those instances. Okay. Now, coming back here. So what happens when you want extra fields that you're not necessarily searching for? So just as a random example, say you want to know the institution name. I know that's not a great example because if memory serves right, I think that's actually a series level field. But nonetheless, let's say you do want institution name. So in good old DIMC days with cfind, what you'd do is you'd add the institution name as a key to your query and you leave the value empty. So that's basically the implicit way of saying, I want that end result, but I'm not actually explicitly searching on it. Now that same way works in DICOMweb. So as you can see here, I'm saying and institution name equals, and it's empty. So that's one way. Oops. Sorry. The other way is to say this explicit way, which is include field equals institution name. So this is an explicit way of saying, I want this as a returned key. I'm not searching on it. So let's try this super quickly here just to see it working. Okay. So I'm going to go back to Postman. I'm going to paste an existing URL that I had prepared on the side. And let's search for institution name. So there you see the institution name was returned. Now, in this study, the institution name was actually empty, which is why it didn't return anything. But the fact that it's present means that it heard what I asked for. Okay. And I'll do the other examples, which is the include field. So again, this is include field equals institution name. And voila, this should also return the institution name as well. All righty. Now, of course, in case you're wondering, you can also use a tag number here instead of the tag name as well, in either one of these. So up here, just using it as a return key or the include field. Now, what happens if you need more than one? You can basically just repeat. So you can see here as an example, include field equals institution name and include field equals referring physician name. So that's basically me asking for both of these to be returned. Now, how do we go from discovery to retrieval? So everything I've showed you so far, you're basically just discovering things like the study, what's within a study, what's within a series. But how do I actually now go and retrieve something, right? That's the interesting part. Now, the simplified version is that I can basically just ask for a study by its UID, and I'm saying remove the accept header. You actually can keep the accept header, but you can specify a specific one. For the simplicity here, I'm going to stick with the accept header being removed, and I'm going to go ahead and send this request. Now, you notice, maximum response size reached. Okay, so the study I asked for was just a little too big. Let's do this at a smaller level. So I'm going to do this at a series level. Remember the hierarchy, right? So there is a study UID over here, and then I'm going to ask for a specific series, okay? So now I'm going to send this, and now you see the gibberish here. If you haven't seen this gibberish before, this is your literal binary DICOM. If you took this and wrote it to file, this would be your DICOMpart 10 file, the usual DCM file that you're used to seeing. And again, it's returned in a multi-part fashion. So if I search for the boundary, you'll see there's 3 of these returned. So it's 3 images within this series that it just returned to me. Alrighty. So that's the retrieval. That's part of the reason why there's a multi-part, because it's a nice way of bundling things. So you can retrieve an entire study in one shot. You can retrieve an entire series in one shot, but you can also just retrieve a single image or instance if you want it. Now, the error you saw for the maximum size returned is an error from Postman. It's not an error from the server. So in real life, nothing actually stops you from retrieving that entire instance in a script or something. Okay. What happens if you want to return a full DICOM header, including private attributes, but you don't want the images? So that's also doable. And as you can imagine, there's a magical URL to do that. So the URL is similar to what you've seen before, but you'd say /metadata. So that will return the raw header. Now, you see I've got the asterisk next to the private attributes. It's not necessarily a 100% guarantee that's going to return all the private attributes. It may depend on the actual implementation you've got, but in the implementation we have within the SIIM hackathon, it definitely tends to work. So let's try this. So I'm going to remove part of my URL over here, and I'm going to replace the series with metadata. So I'm asking for the metadata of this entire study over here. Okay, I'm going to go ahead and hit send. Now, because I've removed my except, it automatically reverted back to JSON. The default format will depend on your implementation. So if you don't specify an accept header, it's up to your PAC system or VNA to decide whether they default to JSON or XML. So it is better to be explicit here. But yeah, in this case, I'm not going to go through it in a lot of detail, but this is actually returning the raw DICOM header without the pixel values. So really handy if you want to go through and dig in for some private attributes or something along those lines. Okay, very quickly, the biggest differences between Water URI, again, that's the old standard. It's not the one that was deprecated, but it is still widely used, versus Water RS. So Water URI was designed to return one object at a time, which is why the responses, if you've ever used Water URI, were never multi-parts. Whereas Water RS was designed to return multiple objects at once, which is why it's a multi-part. Again, it's very similar to email attachments. In fact, if you use a language like Java to handle the multi-part request, literally the classes that you'd use to pull out a multi-part request come from an email package, because that's what it was originally created for. Now, the two have some syntax differences that I'm pointing out here. Not a huge difference. Basically, what you do with Wado is you specify study UID, series UID, and object UID. Wado RS is similar, but just the way you express it is slightly different. So you see the UIDs are the same here. There's the UID 1 to 3, it's here too. There's a series ID, a UID 4, 5, 6, it's here. And then the object or the instance UID is 7, 8, 9, and it's right there too. All right. But remember, the biggest difference is because Wado RS can return things in bulk, you can choose to stop right here after 4, 5, 6, and you're going to get the entire series, or you can choose to stop after 1 to 3, and you've got the entire study. You cannot do that with Water URI. All right. Now, what's the fun with playing with DICOM if you don't get to see the images? So that's what we're going to do today. I don't have time to show both examples, so I'm just going to show the Water RS example, and it's going to be an interesting one. So what I'm going to do is I'm going to bring an existing URL that I have prepared, and I'll walk you through the details of that URL. Okay. So there's a study UID. Okay. There's a series UID, as you can see over here. And then there's an instance over here. So that's the exact image I want. And then at the very end, I add /rendered. So this is what tells Wado that I want this as a JPEG or PNG rather than a DICOM file. And to be more obvious, I'm going to add an accept header, and I'm going to say image JPEG. So that tells it that I want a JPEG image. And I send this. And there's the image, as you can see. So the image came up. All right. So we saw some images. So we know that it works. Same thing can be done with Water URI, as I mentioned before. This is how you do it. You would add one extra parameter that says content type image JPEG. And again, you can also say image PNG if you want a non-compressed version and so on and so forth. Now, there is also support for getting fancy if you want to really let the server do the work for you. So you can resize, you can crop, you can even burn an annotation for some of these things. But I'm not going to cover that today. We'll keep it really simple. Now you're wondering, okay, so this is really cool. I can't wait to use it. Where is this in real life? Do I have it? And the answer is, I don't know for sure. A lot of vendors have partial DICOMweb implementations. Now, some of them are not necessarily advertised. So talking to your vendor is always a good idea. And I know more and more vendors have support planned. Whether they have no support and they're adding the support, or maybe they have partial support and they're enriching their support, okay? However, unlike Fire, one cool thing about DICOMweb is it's not a complete revolution. DICOMweb is an evolution. So if for whatever reason you want DICOMweb today, and your PACS vendor or VNA vendor doesn't have it, there's actually an open source project on GitHub that allows you to retrofit DICOMweb onto an existing PACS or DICOM. So basically, you put this layer as a proxy in between. You can talk to it over DICOMweb, and behind the scenes, it talks to the PACS or VNA over DIMSI. So it's a really cool way of retrofitting things. Of course, it does come with a bit of an added overhead and potential glitches or issues to watch for, but nonetheless, just the option of having that is really cool. If you want to play with DICOMweb, there are multiple ways you could go about that. So the first one, and the one that, of course, I selfishly advocate for, is through SIIM. So we have the SIIM Hackathon server. It's public. It's free of charge to use. You can even experiment with things like STO, so storing things over to it. We reset the server nightly. I can show you how to use it in just a moment. There are also freemium cloud services where you can use a simple tier for free, and then you can move up to a paid tier. There are services from Google and Microsoft. If you want something on premise, like on a VM or on a physical server, Orthanc is a good choice. That's the one that we use for the SIIM Hackathon. There's also DCM for Chi, but of course, make sure you're getting DCM for Chi, the new one, not the old super popular one, because the old one doesn't support DICOMweb. If you decide that you want to try it through SIIM, this is what I recommend. The process is really simple. You will log into SIIM, and then you want to go to this link, and I'm happy to share this link in the chat. You will sign the agreement just to say that you're not going to be uploading any PHI or anything like that to our server, and then you'll be getting your key back in the mail in 24, 48 hours max. The key is sent manually. That's the reason for the delay. And if you do request it, keep in mind there's a chance that when you get the key in the mail, it may end up in your spam mailbox. So keep an eye on that junk mailbox for the next couple of days, just in case it arrives there. And with that being said, I thank you all for your attention, and I'll give it back to Herman.
Thank you. Wow, Mohamed, every time I listen to you, I learn something new. Excellent. Thank you very much. So a little bit of conclusion, so final words, and then we have some time for questions. So first of all, DICOM web services are a complement rather than a replacement. Okay, I need to share my screen first, otherwise you won't be able to see it, right? So DICOM web services are a complement rather than a replacement. So think about it. We're not going to take out the whole infrastructure of DICOM, how CTs work with PAC systems and all the ultrasound work together, but it's a complement, really. The complementary part would be we can use web services, which means very easily to develop applications for your mobile devices, for your tablets, for any web browser. And the good news is, like Mohamed just said, you can actually have an open source front and you really wrap around your existing PAC system. So you could actually do both very simply. Web services speed up the development of new applications. Mohamed used Postman, but basically a simple development environment, you can come up with a new tool, a new gadget, a new app very, very simply. And it really allows for powerful integration like EMRs, mobile displays, and EMRs, most EMRs have web-based interfaces. So you can create a simple proxy, use the existing infrastructure, but implementations are still limited. Sometimes, like Mohammed also said, sometimes they're kind of hidden. You might have to ask. If you actually looked, I actually looked for PACS conformance statements, and there was only very few that I could find that is a very nice specification of the full VADU, Kido, and so features. So either most vendors still hiding it, or they don't want to advertise it. But one of the things that you have to realize also that at the IHC Connectathons, for several years, we have been testing XDSI. We use VADU as the core. So there have been lots and lots of demonstrations, lots and lots of connectathons, meaning that we have actually validated these implementations. So it is kind of, they are either hidden or under the covers, but there's no, it's really not necessarily immature. It's definitely a mature standard, right? We're actually waiting kind of to develop it on a large scale. And also most of the zero footprint viewers use DICOMweb anyway to start. Okay, so I'm ready to give it back to Bradley. Any questions, Bradley, for Mohammed and myself? Go ahead.
Fantastic. Well, before we get any further, thank you both so much, as always, for the phenomenal information, and of course to our attendees for providing us so many questions. We from SIIM would be remiss, however, if we did not mention that in just 2 short weeks, the SIIM 21 annual meeting is going to kick off. And so if you really enjoyed today's conversation, you want to dive deeper into these materials, you can do so by joining the IIP Toolbox Introduction to Anonymization, DICOM Headers, Scripting, and SQL, featuring none other than the 2 gentlemen who are on the screen right now. They'll be able to have an office hours session during the annual meeting with pre-recorded content, templates, and all sorts of other fun stuff. And of course, as any IIP knows, we are always looking for new tips and tricks to bring in. And so the other learning lab that we'd like to recommend to this audience is the IIP Gear Up, a suite of sweet tools featuring none other than Don Dennison, Nikki Fennell, and more. So for more information on that, folks, don't hesitate to jump on over to the SIIM 21 annual meeting website located at siim.org. So diving into a few of these questions, and Mohammed, I think that you already addressed this in chat, but just to bring it back out for everyone, is using standard secure web addresses like HTTPS HIPAA compliant?
Yeah, thank you, Bradley. I'll take that one because I already just answered in the chat, but just for the benefit of everybody. So DICOMweb can run over HTTP, aka non-secure, and HTTPS. Of course, highly recommend you do HTTPS. All the examples I showed were HTTPS. But usually what happens is that vendors will have additional mechanisms on top of just the fact that it runs on HTTPS to secure it. So some vendors may keep it as simple as it's a username and password. Some vendors may use more elaborate method. The method you saw today that we use for SIIM is we use an API key, and the one I use is generic, so that's why it looks readable. But the ones we use otherwise are usually more cryptic. Some vendors will go as far as using things like OAuth or even HTTP certificate mutual authentication. So definitely possible.
Fantastic. Herman, anything to add to that?
Yeah. When people ask HIPAA compliant, it's almost a wide open question because 70% or more of HIPAA compliance deal with policies and procedures. So even if you have a secure connection using HTTPS, which provides the encryption, even if you do authorization, right? If you have a yellow sticky on your monitor that shows you the password, you're not HIPAA compliant. So, so this allows for HIPAA compliance bundled with the right policies and procedures, right? And definitely will address the encryption and authorization. So I just wanted to add that because sometimes people say, oh, is it HIPAA or GDPR compliant? You really, in practice, need to also make sure that you always have the right policies and procedures in place to facilitate HIPAA compliance. Thank you.
Fantastic, sir. All right, well, I think the question of the hour, and we've circled around this a few times, when do you expect DICOMweb replacing the, or to be replacing the traditional DICOM?
Yeah, let me maybe take a shot first. So, and then actually, you could actually ask the same question, but about when will Fire replace HL7? And I think they're kind of in parallel. right? FIRE is the equivalent, the companion from DICOMweb, both use web services. So it will definitely will take a while. And the first implementation will be what I call niche implementation. Upload a picture from your iPhone or from your Android phone or from your tablet. Upload pictures into the VNA using web services. Access images via a web browser of your EMR, right, from the VNA. So there will be on the peripheries, let's say on the periphery, anytime that you make a connection, either to the outside world or using some kind of internet infrastructure, these DICOMweb and FIRE will be definitely advantageous because it's, you use existing tools, use existing infrastructure. So that's where it will start very slowly. Now, when will the CT scanner start talking DICOMweb to the PAC system? I don't know. I don't know actually what it might happen, because why would you change something that works unless it gives a major benefit? The only benefit I could think of right now is that there's a lot of talk about zero trust from a cybersecurity perspective. You cannot trust anyone anymore. Even a service person coming on with a flash drive and tries to upload the latest and greatest software release or download it from the internet to the CT scanner or the ultrasound could be a virus. So it could be one of the main advantages of using DICOMweb will be the built-in, so to speak, the built-in security, the mechanism, the whole certificate, the whole authorization. So if there's a big push for zero trust and there's a big push for deploying security at the really local level, I think that, from my perspective, could probably be the major incentive. So what do you think, Mohammed?
I totally agree with you, Armin. And honestly, I don't necessarily see DICOMweb as a straightforward replacement for DICOM. I see it as a complement to it, in the sense that this is a new way of doing things that is a bit easier, but it's not necessarily the way for everything. So yeah, there might be a day when we see CT scanners doing things over DICOMweb, but I don't think I'm personally in a hurry for that, because I don't feel like this is a problem they try to solve. The problem they try to solve is, what if I'm a system admin that I'm trying to round up some studies for AI research or something like that? I can get these a lot easier over DICOMweb than traditional DICOM DMC.
Yeah, good. Thank you, Matt. So any cloud connection, for example, that would be perfect. Yeah, that would be a good application. Yeah. Okay, we have time for one more question. Go ahead, Bradley.
Well, I think it's interesting just hearing the conversation that both of you had, and something that a few members of our audience are interested to hear more both of your thoughts on. We keep talking about connections. We keep talking about institutions. We keep talking about, here at SIIM, users, industry coming together. How will somebody know if their vendor supports DICOMweb? And could there be any type of disconnects or challenges in trying to get that style of partnership moving forward?
You have any experience, Mohammed?
I do. I cannot name any vendors today, not to embarrass anybody. I would say you can ask is probably the easiest thing to do. Sometimes you may find that the people you're dealing with as a vendor are not up to date with their knowledge. So they may not even know what DICOMweb is, or they may not know if they support it or not. So in my experience, one time with one vendor, I've actually had to go dig through the conformance statements that they have publicly on the internet, and came to the service guys and said, look, your server supports it. Can I have it, please? Now, of course, that's not to say they're definitely going to give it to you and for free. That's a different story. But at least the fact that you know that it exists or doesn't is a start.
Yeah, so look at ask for the conformance statement, and then ask for the right people to give you the conformance statement with the right version and the right implementation class UID. You can double check. So yeah, sometimes dealing with vendors could be a little bit challenging, but the good news is now we can refer them to a SIIM webcast about DICOMweb if they want to learn more. That's it for us, Bradley. Thank you.
Fantastic. Well, gentlemen, thank you again, as always, for jumping online, sharing your expertise, and of course, being so gracious about it. And to our wonderful attendees, thank you for staying the entire time. We know that it's always difficult, especially as we start entering the summer months, to schedule a call in the middle of the day. We hope that you'll continue to join us as we move forward, whether that's at the SIIM 21 annual meeting and those learning labs we previously mentioned, in future IIP tips and tricks sessions, where we'll be having the third and final conversation on project management, or of course, during the enterprise imaging webinar series, which will be moving into data migration territory in just a few short weeks. We hope that everyone has a fantastic rest of the week, and we look forward to talking with you all soon. Gentlemen, thank you again.
Thanks, everyone.
Take care. Appreciate it.